Hi, everybody. Welcome back to Dave's Math channel. This is my continuing feature on the Math Lovers book. And I'm done with loops. I had, I think, 4 videos in a sub-series on loops, which is part of sequential programming, which is section 8.4 of volume 1. Chapter 8's on computation, kind of a long chapter. But I'm continuing my series on section 8.4, sequential programming. And the next thing I'm going to talk about is functions. So functions are something that are widely used in every programming language. Sometimes they're called subroutines. But I think every subroutine is basically a function. It's something that does some just think of it as part of the program that does some particular task. That's the way to think of function. Anyway, let's begin. So here's the general form of a function. We give it a name. Here I'm just calling it f, kind of an unimaginative name. But every function has a type. In this case, our function type is an int. That means the output's an int for this function. Remember, there's different types of data. And I'm modeling this after C and data. In C, you have data types int and character and float and long. I'm not going to get into all the different types, but int is really just an integer, usually 32 bits or 64 bits. And in this example, the input is also an int. So we have a single variable, which I'm calling input. And it doesn't have to have just one variable. It can have multiple variables, or it doesn't even have to have any variables. And it doesn't even have to return anything either. A function that doesn't return anything is called a void function. As a matter of fact, main. The main program is a function. It's a void function. It's a void function with no arguments. But usually you have functions with a type, they return something, and they usually take inputs too. So this is just the general form of the simplest type of function, a univariate function, it's called, is a function of one variable, one input, one output. So you have to, declare the output in your function. You might have to declare other variables too that you might need for computing, and then you have some code for computing the value of your function, and then it returns the output. So that's what a function does. It takes an input and gives an output. Pretty basic. I mean, that's kind of the basic form of any computation, really. Uh, so anyway, that's what a function is. And I'm just going to give you a couple examples. So a simple example would be this function called double. And again, it's an int function that takes a single int variable. So I have this function called double that has a input x. I'm calling x, and the output is double of x. And as you might expect, double of x is just 2 times x. So that's all this thing does, one line function. It takes in x and it returns 2 times x. Pretty simple. So if you input 4, it would give you 8. If you put -5, it would give you -10. So on. Yeah, that's a very simple function. And let's look at a little bit more complicated example. Like I said, functions don't have to be univariate. They can be multivariate, in this case, bivariate. So now I have a function called product, which has two inputs and also a single output. So I'm going to define the function product of x and y. X and y are both ints, and again, the output's an int, and it just returns x times y. Not a very useful function. You could just use that with the times operator, but you could define more complicated functions. So I think you kind of get the idea. That's what functions are. And you might wonder, when to use functions. Well, functions have to be called from the main program. So every program you write starts with a main program. The main program in C is a function itself. It's just this void function called main. But then you might want in your main program to do other tasks. You might want double numbers or triple numbers, or you might want to calculate the average grade of your students, whatever you want to do. You're probably going to want to write some functions to do what your program's trying to do. So the main program calls all these functions to perform all these tasks. So the program is going to have kind of a hierarchical structure. the main program's on top of the hierarchy, and then it calls a bunch of other functions, and functions can call other functions too. So you get kind of a tree structure to the functions and the way they're called. And functions can even call themselves. When your functions are called themselves, they're called recursive functions. I'm going to get into those next video on this on the Math Lovers book. I'm not going to talk about this today, but you can get very powerful recursive functions. Functions that call themselves. A good example of that is a factorial function. Anyway, and now I'm just going to give you an example of how you would call a function. So, both you had a program where you want to, read in a number, an integer, and double it. So this function, this main program, is going to call a function called double, and here's how it works. It says enter an integer. That's a prompt for the user, and then the user inputs a number x, and then it says twice x is double x. So now it's calling another function called double. So it has to run some new code. And this thing double x means that it has to look for a function that's being called by the main program called double, and we have to declare the function before we write our code, just like we would declare the variable x. And then below our code, we have the function double, which I showed you this function already, just refers to turns 2 times x. This is a very simple example. We didn't have to use the function double, but we might have been doing something more complicated where we did require a function. So that's kind of the idea of using functions. Anyway, so that's a kind of a brief overview of functions and how they're used in programming. And that completes my video for tonight. So thank you for watching. Long live math, and I'll see you guys next time. Bye.